Right friends, welcome back to News Analysis and Features. We are going to discuss two aspects this week. First is India and its pledge to reduce carbon emissions. Second one is Astrocyte, what do you understand by it? And first one is India's pledge to reduce carbon emissions, and India recently submitted its INDCs, and you may ask what is meant by INDC. INDC is intended nationally determined contributions. That means nations are coming forward with their targets. Instead of imposed by somebody, nations are coming forward with their targets for reducing carbon emissions, and India submitted its intended nationally determined contributions with regard to the carbon emissions, and these are committed by each country voluntarily, and these will be discussed at the forthcoming climate negotiations at Paris. And India submitted their commitments to United Nations Framework Convention on Climate Change. And in this context, I told you in the lecture part why these greenhouse gases are so important. Let me remind you once again, in the sun, because of fusion process, a lot of radiant energy is released. That energy is transmitted to earth in the form of electromagnetic radiation, and in the atmosphere this carbon dioxide, methane, nitrous oxide, these gases, and predominant gas is carbon dioxide, these absorb this electromagnetic radiation, and because of which there is possibility of increase in the heat or increase in the temperatures, and the world wants to reduce it to up to 2% in comparison to 1750 levels. Why 1750 was taken is, that is the pre-industrial era, and please don't forget, because of rise in temperatures, glaciers will be melted, and because of which there is possibility of flooding of low-lying islands and coastal areas. There will be a lot of damage to the ecosystem. Because of this, world wants to reduce the greenhouse gas emissions or carbon emissions. In this backdrop, now all the countries are coming forward with their INDCs, and India also submitted their INDC. And we have discussed in the lecture part, there are primarily four things. One is India aims to cut its carbon emissions per unit of GDP by 33 to 35% by 2030 from 2005 level. Second point is India will achieve 40% of its total electricity generation by the year 2030 with 40% of non-fossil fuel based energy. Third one is will create carbon sink of 2.5 to 3 billion tons equivalent of CO2, and the last one is at least $2.5 trillion is the amount required for meeting these goals by the year 2030. We have discussed in the lecture part. Now let us look at the emissions of various countries. Left side, if you look into this PPT, 8 key areas are announced by India, and if you look at the right side, I have given top 5 carbon emitters. I have taken it in the form of percentage of total emissions in the world. If you look at it as percentage of total emissions in the world, China is emitting more at 25%. So in the world, the share of China in the carbon emissions is 25%, followed by United States of America at 14%. That means these two countries put together are responsible for 40% of total carbon emissions, because China industrialized and has grown at more than 10% for the past 20 to 30 years, and America is already industrialized country. Their carbon emissions are more because of lavish lifestyle, energy consumption is more, most of the energy is coming from coal based sources. That is the reason why advanced economies are being blamed for carbon emissions. The situation of China is because of massive industrialization of that country, and in recent times, it has grown at around 10%. Because of that, the carbon emissions in that country are very high, and please don't forget, China is the largest emitter of carbon in the world, and 1/4 of the world's emissions are from China. Third is European Union. If you take it as a block, third place is European Union, but if you take as individual country, India stands at third position at around 7%. We are responsible for 7% of global carbon emissions, whereas United States of America with just 30 crore population is responsible for 14% of emissions, but differentiated responsibility should be there. For reducing the carbon emissions, there should be differentiated responsibility, because industrialized countries are mainly responsible for spoiling this planet. And second thing is, if you look at the tons of emissions per capita, United States of America stands at around 20 tons per capita, and please mind it, these figures vary from source to source. Don't take them as sacrosanct. There may be some variation from various news reports, but in general, please look at it. United States of America is responsible for 20 tons of emissions per capita, followed by Russia with 16 tons per capita, Japan with 10 tons per capita, and India stands at 10th position with around 2 tons per capita, which shows that we have to grow a lot. Our people are below poverty line. They have not much access to various energy sources. They are not able to afford luxurious lifestyle, and tomorrow India may grow at 10% and people will come out of poverty line. After that, our energy requirements may grow. That's why it is not justified, it is not in the natural justice to ask all the countries on the same platform to reduce carbon emissions. However, India announced their emissions voluntarily. And look at the next issue, emission cut plans by other nations. Now we have learnt about India. If you look at it, United States of America, 26 to 28% of 2005 level by 2025. And please don't forget, they have already reached peak stage. And China, 60 to 65% of 2005 level by 2030 per unit of GDP. And other countries have also given their INDCs. And finally, what are the points which emanate from India's INDCs? Let us look at it. The first point is, we are not a part of the problem. As the previous slide shows, the industrialized countries are mainly responsible for carbon emissions. China and USA put together are responsible for almost 40% of carbon emissions. We are not part of the problem, but we are taking part in the solution. That shows the magnanimity of the developing countries. The second important point is strong climate plan. That means India already committed by 2022 1,75,000 megawatt of energy will be renewable and clean energy sources. 1,75,000 megawatt will be from solar, wind and other sources, but not from fossil fuels, and this will be taken to 3,50,000 megawatt by 2030. That means India is making more emphasis on renewable energy. The third point is emission intensity reduction was also increased. Previously, India committed 20% by 2020, but now India increased the target to 35% by 2030. That means there is increase of 75%. The fourth point is coal cess already being imposed, and additionally climate tax may also be thought of in future on the affluent persons who are consuming and who are responsible for more carbon emissions. So from Indian perspective, whatever India has done is in the right track, keeping its status as a still developing country, and the success depends on two things. First and the foremost is the availability and access to the cost-effective clean technologies. Second important point is the financial resources. $2.5 trillion at 2014-15 prices, and arranging this much of financial resources is not an easy task. So, access to the cost effective clean technologies is the first challenge. The second challenge is for India arranging the financial resources, right? Let us hope detailed discussion to take place with regard to other countries' INDCs in the Paris summit, which is going to be held from November 30. Right friends, look at the second issue of the week, Astrosat. What do you understand by it? And several countries at several places will have ground observatories. They will be established on the ground, maybe on the hill. But having space observatory is at present the prerogative of only few countries. Very few countries in the world have space observatory. And all of you are well aware about Hubble telescope. Hubble telescope is space observatory established in the year, probably in the year 1990, 25 years ago, sent by NASA with the assistance of other agencies, and now India for the first time kept this Astrosat in the orbit. What is so significant about this Astrosat? And before going into further details, this Astrosat is the joint work, or you can say the combined effort of 4 more organizations. In addition to ISRO, the organizations which involved with it are Tata Institute of Fundamental Research, Mumbai, TIFR, the famous institute in Mumbai. Second is India Institute of Astrophysics in Bengaluru. Third one is Inter-University Center for Astronomy and Astrophysics at Pune. Fourth one is Raman Research Institute at Bengaluru. These 4 organizations are associated with it, and most of the payloads come from these organizations, right? So, this is special about this Astrosat, and we have discussed previously in the lecture event that PSLV C-30 rocket successfully placed this Astrosat in orbit. This is around 650 kilometers above Earth, and its service life is around 5 years, and it can perform multi-wavelength observations of various astronomical objects. There are several astronomical objects in the universe which can be seen perfectly and which can be assessed properly when they are viewed in multi-wavelength observations, right? And before going into it, I would like to dwell a little about the electromagnetic spectrum, right? We have discussed in connection with INDCs that Sun releases abundant energy that transfers to Earth in the form of electromagnetic radiation, but that electromagnetic radiation is in the form of several frequencies. That electromagnetic radiation, that frequencies vary from radio waves right up to gamma rays. Radio waves will have more wavelength or less frequency, and when you go up, the frequency increases, and the atmosphere blocks ultraviolet rays as well as X-rays. In fact, ultraviolet rays as well as X-rays do not reach Earth because atmosphere blocks them. Atmosphere blocks most of these rays, and if you look at the distant objects like neutron stars are very small stars, and if you look at neutron stars and other distant objects in the universe, almost atmosphere blocks entire radiation from those distant objects. When the distant objects are to be viewed from ground satellite, they may not be able to view them through the electromagnetic spectrum of this ultraviolet and X-rays. In the ultraviolet band and X-ray band, ground observatory may not be able to view the distant objects. That is the major problem with the ground observatory. So far, for our astronomical observations, we are dependent on other countries for getting data viewed through ultraviolet spectrum as well as this X-ray band. Right? Now with this space observatory, scientists simultaneously can view distant stars, neutron stars or black holes. That means these are the objects in the universe. I am not going in detail into them. The distant objects in the universe can be viewed by our scientists, and for that purpose this will be highly useful, right? And the advantages of a space observatory Astrosat I have given in this PPT, and please go through them. I will explain one by one. The 5 payloads will cover the full spectrum of wavelengths simultaneously. That means you can view the distant objects of the universe like neutron stars and other distant objects. Simultaneously you can view in different wavelengths from visible light to ultraviolet and X-ray bands. In all the bands you can view them simultaneously. When you are viewing the distant object simultaneously, the real picture will be known to you. The second important point is to understand celestial objects. It is necessary to see the objects in different bands at the same time. This is possible when you have space observatory. Otherwise, what will happen? You will observe from ground observatory and you will take data from NASA or European Space Agency, and they might have seen some different time. That's why it is not that easy to collaborate data of our observatory along with their space observatory. The third point is, by studying the high frequency radiation bands, we can carry out our own research of neutron stars or newly born stars or exploding stars or the spiraling hot gases in the universe, and these things are possible. We can view them without much difficulty when we have our own space observatory. Then last point is, we need not depend on NASA or European Space Agency for getting the details of observations from these high frequency bands by their satellites, right? The last PPT, please go through it. The scientific objectives of Astrosat mission are: first one is understanding high energy processes in binary star systems containing neutron stars and black holes. Second important point is estimate the magnetic fields of neutron stars. Third one is study star birth region and high energy processes in star systems lying beyond our galaxy. Fourth point is detect new briefly bright X-ray sources in the sky. The last one is perform a limited deep field survey of the universe in the ultraviolet region, right? So let us wish good luck to ISRO on the eve of launch of Astrosat, and astronomical institutions also deserve a lot of praise from Indian community because of their contribution to ISRO. And with this, let us say good luck to ISRO and astronomical institutions. Have a nice day. Thank you.